Baiklah teman-teman, di sini kami akan menjelaskan tentang unsur golongan 12 atau Element of Group 12 yang kami kutip dari buku Inorganic Chemistry, a second edition oleh Catherine A. Hasselcroft and Alan G. Sharp. Okay, I will start. You are confused. What are the elements in group 12 and why is it called group 12 while the element has cation 2 plus? And then, how is the electron configuration? Nah, teman-teman pasti bingung, apa aja sih sebenarnya elemen yang terdapat pada grup 12 ini? Kemudian, mengapa dia disebut dengan grup 12? Padahal dia memiliki kation 2 plus. Kemudian, bagaimana konfigurasi elektronnya? Oke, saya akan menjelaskannya. Kita lihat dulu. General description atau gambaran umum. Zinc is a chemical element with the symbol Zn, atomic number 30, and the relative atomic mass of 65.39 G per mole. Discovered by Andreas Markgraf in Germany in 1764. Yang pertama, zinc. Zinc ini adalah unsur kimia dengan simbol Zn dengan nomor atom 30 dan nomor massa 65,39 gram per mol. Pertama kali yang menemukan zinc ini adalah Andreas Markgraf di Jerman pada tahun 1764. Langsung kita lanjut yang kedua, elemen kedua yaitu cadmium atau Cd. Cadmium is a chemical element with the symbol Cd, atomic number 40H, and the relative atomic mass of 112.411 G per mole. Discovered by Friedrich Stromeyer in Germany in 1817. The last, cadmium adalah unsur kimia dengan simbol Cd dan memiliki nomor atom 48 dan memiliki nomor massa 112,411 gram per mol. Dan ini juga pertama kali ditemukan oleh Friedrich Stromeyer di Jerman pada tahun 1817. Okay. And the third, mercury. Mercury is a chemical element with the symbol Hg. Atomic number 80 and the relative atomic mass of 200.59 G per mole. Discovered by GSI in Germany on February 9, 1996. Jadi, merkuri ini juga unsur kimia dengan simbol Hg dengan memiliki nomor atom 80 dan nomor massa 200,59 gram per mol. Dan ini pertama kali dijumpai oleh GSI di Jerman pada Februari tanggal 9 tahun 1996. And then this in the group 12 have a cation 2 plus but are not the same as group 2. Mengapa? Mengapa pada grup 12 ini memiliki kation 2 tetapi tidak sama dengan grup 2? Ini disebabkan oleh perbedaan pada kemudahan terdistorsi kulit D yang terisi penuh. Jadi, pada grup 12, subkulit D terisi penuh, sedangkan pada grup 2 tidak. Makanya, dia lebih mudah terdistorsi pada grup 12. Okay, I will explain about the electron configuration. The first Zn or zinc. Zinc have a atomic number of 30. So, configuration electron of cell is 2H 18 and 2. And the configuration electron of subcells is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, dan 4s2. Dengan diagram orbital sebagai berikut. Nah, pada subkulit D terisi penuh. Nah, disinilah dia tadi pembedanya pada golongan 2. Golongan 2, subkulit pada kulit D tidak terisi penuh, sedangkan pada golongan 12, subkulit D terisi penuh. And the last, CD atau cadmium have a electron configuration of cell is 2, 8, 18, 18, and 2. And electron configuration of subcells is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2. Nah, this is has a 2 cation. So on the subcell D is a full, terisi penuh pada subkulit D, 4D. Nah, sama seperti zinc tadi, makanya disebut dengan golongan 12 karena terdistorsi. Kemudian Hg atau Mercury have a electron configuration in cell is 2, 8, 18, 32, 18, and 2. And configuration electron subcells is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6, 4f14, 5d10, dan 6s2. And dengan diagram orbital sebagai berikut. Dan pada subkulit 5D juga terisi penuh, sama seperti unsur zinc dan juga unsur pada kadmium. Nah, inilah konfigurasi elektron pada golongan 12.
Is the ionization energy. Ionization energy is the energy needed to release one electron in a gaseous state. From the table, we can see that the ionization energy of zinc are 906.1 and 1733. The ionization energy of cadmium are 876.5 and 1631. And the ionization energy of mercury are 1007 and 1809. From this, it can be concluded that in one group, namely from zinc and mercury, the ionization energy tends to get smaller. This is because the radius of the atom is getting bigger, so that the attraction of the nucleus with the outer electron is getting weaker. We can see that from here. This is the order of ionization energy. But we can see from the table, the mercury, except for the properties, because the ionization energy is bigger than zinc and cadmium. This difference is due to the fact that 4f orbitals are not a good shield for outer cell electrons when compared to electrons in other inner subcells. This results in an effective nuclear charge and smaller than expected mercury atom size. As a result, mercury ionizing energy is higher than zinc and cadmium. Next is atomic and ionic radius. From this table, we can see that the atomic radius from zinc is 1.25, atomic radius from cadmium 1.41 and atomic radius of mercury is 1.44. The atomic radius from the group 12 have the order Zn smallest than cadmium but similar with mercury. The increases in radius from Zn to Cd is due to the addition of higher orbit in cadmium. This is due to the increases in atomic number, so that more electron shells and the distance of nucleus from the outer electrons farther. But in this atomic radius from cadmium and mercury very similar due to the lanthanide contraction. You can see that CD similar with mercury. Mercury is after lanthanides Ce58 to Lu71. Therefore, increase in orbit number in mercury is counterbalanced by lanthanide contraction. Hence, CD and Hg have similar radius. We can see that from this table. From the ionic radius of zinc is 0.74, ionic radius of cadmium 0.95, and ionic radius of mercury is 1.02. From this table of ionic radius, we can see that the order of ionic radius increase from Zn plus 2 to Hg plus 2.
I will explain about the definition of boiling point, melting point, and oxidation state. Boiling point is the vapor pressure of the liquid becomes equal to the atmospheric pressure of the liquid's environment. Melting point is the temperature at which it changes state from solid to liquid. Temperature at which the solid and liquid form a pure substance can exist in equilibrium. As heat is applied to a solid, its temperature will increase until the melting point is reached. Oxidation state is the total number of electrons that an atom either gains or loses in order to form a chemical bond with another atoms. Melting point. Melting point of zinc is equal to 419.53 degrees Celsius, and the melting point of cadmium is equal to 321.07 degrees Celsius, and the melting point of mercury is equal to minus 38.83 degrees Celsius. The question is why mercury has low melting point. The electrons in mercury atoms are bound more tightly than usual to the nucleus. In fact, the s electrons are moving so fast and close to the nucleus that they exhibit a relativistic effect, behaving as if they were more massive than slower moving electrons. It takes very little heat to overcome the weak binding between mercury atoms. Mercury is different. It is not reactive and its neighbor in the periodic table. It doesn't conduct heat and electricity as well as other metals, and it is a liquid unlike other metals. The electronic structure of mercury helps explain mercury's reluctance to react with other materials or form bond with other mercury atoms. Most metal atoms share the other electrons with other metal atoms. In fact, all of these shared metal electrons exist as a diffuse sea of electrons. It is the extended nature of this sharing that makes metal good conductors of heat and electricity. The fact that the metal's electrons are shared provides a strong bonding interaction between metal atoms that gives metals their solid structure. None of this applies to mercury. With its very shared electron configuration, it is very reluctant to form bond even with other mercury atoms. One additional, Interesting effect makes Mercury even more reluctant to share its electron. Special relativity suggests that the far larger nuclei, and Mercury with atomic number 80 is large enough for the effect to apply. Electron exists as a diffuse sea of electron. It is the extended nature of this sharing that makes metal good conductors of heat and electricity. The fact that the metal's electrons are shared provides a strong bonding interaction between metal atoms that gives metals their solid structure. None of this applies to Mercury. With its field-shaped electron configuration, it is very reluctant to form bonds even with other Mercury atoms. One additional, interesting effect makes Mercury even more reluctant to share its electron. Special relativity suggests that the far larger nuclei, and Mercury with atomic number 80 is large enough for the effect to apply. Electrons will begin to travel closer to the speed of light. In turn, their mass will increase, and as mass increases, orbital radius increase. The electron is closer to the nucleus, more attracted to the nucleus, and less available for bonding. These two effects, filled outer electron shell and contraction of the outer orbital closer to the nucleus, combine to make Mercury reluctant to form bonds, even with other Mercury atoms. It is this lack of electron bonding between Mercury atoms that makes it melt and boil at such a low temperature. The boiling point. The boiling point of zinc is equal to 907 degrees and the cadmium equal to 767 degrees Celsius, and the boiling point of mercury is equal to 356.73 degrees Celsius. Boiling point of transition metal is greater than the boiling point of group 1 and 2 metals. This is because transition metals have smaller atomic volumes than group 1 and 2 metals, because additional electrons are being progressively added to the inner atomic orbital, resulting in stronger attraction to the nucleus. Oxidation state. Oxidation state of zinc. In its compound, zinc is usually in the positive 2 oxidation state. Oxidation state of cadmium. In its compound, cadmium is usually found in the positive 2 oxidation state. Oxidation state of mercury. In its compound, mercury is found in the positive 1 and positive 2 oxidation state. The mercury 2 or mercurious ion is actually a diatomic ion with a formula of Hg2 multiple plus 2, while the mercury 2 or mercuric ion is a monoatomic Hg multiple plus 2 ions. Zinc and cadmium also can form a diatomic univalent cations, but the mercury bond is much stronger than the zinc bond or the cadmium bonds, and the univalent zinc and cadmium cations are not much important.
12 group element. Zinc tardies quickly in moist air. Cadmium slowly oxidizes in moist air. But mercury is less reactive than zinc and cadmium. The reaction of mercury with oxygen only become applicable at temperature of about 350 degrees Celsius. But above 400 degrees Celsius, mercury oxide decomposes back into the elements. Reactivity with oxygen, sulfur, phosphorus, and the halogen. Zinc and cadmium combine with oxygen, sulfur, phosphorus, and the halogen on being heated. Mercury also reacts with this element except phosphorus. None of three elements react with hydrogen, such as water in under normal condition, or carbon, or nitrogen. The solubility of the elements depends on the temperature and pH. When the pH is very neutral, the elements are insoluble in water. However, hot zinc and cadmium react readily with steam to produce zinc oxide and cadmium oxide but not for mercury. Non-oxidizing acid dissolve both Zn and cadmium with the evolution of hydrogen and also react with oxidizing acid
but more complicated depending on the concentration and temperature. Mercury reacts slowly with oxidizing acid such as hot concentration of sulfuric acid and concentration of nitric acid. But mercury is reactive to non-oxidizing acid. Zinc is the only element in 12 group which dissolve in aqueous alkali base. Now we are going to magnetic properties of 12 group. There are three kinds of magnetic properties. There are ferromagnetic, paramagnetic, and diamagnetic. Most of the transition elements show paramagnetic behavior. We can see from the d orbital that responsible for the magnetic properties, from the unpaired electron in d orbitals. The paramagnetic or magnetic properties of the transition metal increases on moving from left to right as the number of unpaired electrons increase from 1 to 5. A substance which contains an unpaired electron when placed in a magnetic field interacts with the applied field. Consequently, an attractive force is exerted and paramagnetic property is shown. So, what is the paramagnetic property? A substance that are attracted by the magnetic field are called paramagnetic. Paramagnetic property is only shown when the substance contains one or more unpaired electrons. When a substance acquires a permanent magnetic moment, it's known as ferromagnetic. On the other hand, we also have substances which are repelled by magnetic field and are called as diamagnetic substance. A substance shows diamagnetic property when it contains only paired electrons. So how about the 12 group elements from zinc, cadmium, and mercury? We can see from the electronic configuration of the orbital, which is the all element is diamagnetic because it only paired electron. It contains only paired electron.
The next is application. So, the application for zinc is to coating iron or steel to prevent the rust. And then the next is used for battery materials. Zinc and its alloy are used for metal molding, electricity plating, and powder metallurgy. The next is zinc oxide. The zinc oxide is used for cosmetic industry, especially soap. It's used for prevent our skin from the drying. And the next application for zinc oxide is used as the white pigment in paint or ink. The next is zinc sulphide. It's used as a phosphorus pigment. And for zinc chloride, is used as a deodorant and for preserving wood. The next is zinc sulfide for coloring, septic or to prevent the bleeding, and as a supply of zinc in animal food and fertilizer. The next function is an important function for our body, especially in our metabolism. The function of zinc in our metabolism is to run the enzyme to doing the metabolism like carbohydrate metabolism, protein metabolism, or even the fat metabolism in our body. The next is application for cadmium. The cadmium can use as manufacturing solder in nickel-cadmium batteries. And then cadmium compounds are used as phosphorescent coating in TV tubes. The next is cadmium sulphide. This compound is used as a pigment. The pigment that produced from this compound is yellow, and also this compound is used for semiconductors and phosphorescent materials. The other one is cadmium selenide. It's used as a pigment which produces the red pigment and for semiconductors. The next application is for mercury. So this is the common application for mercury, which is used for the dental amalgam material, insecticide, the filling of thermometers, barometers, and other specific scientific equipment. So even the thermometers or barometers can fill by alcohol or water, but the best element in thermometer or barometer is mercury. The other application is for mercury to sulfide as a pigment. Mercury to chloride is used in the manufacture of other mercury compounds. The other one is mercury 1 chloride is used in calomel cells and as the fungicide. And then the last is mercury sulfate as the catalyst in the production of acetaldehyde from acetylene and water. The next is the color of the 12 elements. First is zinc. Zinc color is light gray. Zinc color is the one of 12 elements which have the different color. And for the other element, which is cadmium and mercury, has the same color which is silver. So zinc is the different one which have the light gray color, and for cadmium and mercury we can look, they have the same color which is silver.
Hello, I'm Nadya Ulfa from Bilingual Chemistry Education 2017.
Hello, let me introduce myself. My name is Putri Rizkika Ramadhani and I'm from Bilingual Chemistry Education Program 2007.
Hello, let me introduce myself. My name is Tati Justika Gea from Bilingual Chemistry Education Program 2017.